How about we now pause to see if Newton could have done the calculation extending the gravitation that he was familiar with extending to the orb of the moon. Let's just see if that'll work out, especially if somebody has a calculator. Somebody get a calculator out. Okay, so we have G at the surface of the Earth. G at a distance r should be G at the surface of the Earth times the radius of the Earth over the radius squared. Let's see if we believe that. So the gravitational acceleration should fall off like distance squared. So it goes like 1 over r squared at the particular value of r equal to the radius of the Earth. Then we get g, which is about the 10 meters per second squared. Okay? So the question is, what do we know about the moon to see whether its acceleration agrees with this expression? So how long does it take the moon to orbit once? Yeah, so the period and the distance to the moon is 384. Now, I'm not exactly sure what unit Newton used. It was definitely not meters. But from astronomical observations, he did have at least a reasonable approximation for the distance to the moon. Okay, so based on the fact that the moon goes in a circle around the Earth, can we figure out what acceleration the moon experiences? How would I get that? Okay, the acceleration of the moon should be omega squared r. That is to say, 2 pi over the period squared r moon. So the question is, if we compare 9.8 meters per second squared times the radius of the Earth over the distance to the moon, does that doesn't equal 2 pi over p squared times the distance to the moon? So let's see. Radius of the Earth, if you recall, was 6,400 kilometers. So calculator dudes, one on the left, one on the right. Do you have either side?
On the left, I get 2.7 times 10 to the negative 3.
2.7 times 10 to the negative 3. And what units would that have?
Meters per second squared.
Meters per second squared. And on the right, we have to convert the days to seconds by multiplying by 24 and 3,600. Somebody got it?
I get 2.72 times 10 to the negative 3.
3 point.
2.7 times 10 to the negative 3 also.
Oh, 2.7. So when Newton figured this out, when he connected terrestrial gravitation to something that could extend as far as the orb of the moon, he did something radical. And that is, he broke the philosophical and intellectual barrier that people had erected between Earth below with its transformations and decay, and the heavens, which were allegedly perfect and running round in circles. And he said, look, we have the same laws down here as they have up there. And so he tremendously altered the picture we have of our place in the universe.